Tonight's homework involves practicing some density problems using the density formula. And just to review that with you, at this point you should know what it is because you learned it in physical science. But just to remind you, density is equal to mass divided by volume. So anytime you're given a mass number and a volume number, you just have to divide the two to find density. So you have 4 problems, 4 rocks to identify, and you actually have a table with the set density to identify these rocks. So for each of these problems, you're going to calculate density and then match that number up to the table above the problems to identify which rock you're talking about. So for rock number 1, it says this rock's mass is 24.03 grams. And the volume is 8 9/10 centimeters cubed. So you always start out by writing your formula. G is equal to M divided by V. And just a warning, for this year, you actually are supposed to know this on your own without me giving you the formula. So I'll give it to you on here, but when we take a quiz, you're going to be responsible for remembering it yourself. So the mass we have to plug in is 24 3/100, and we'll divide it by 8 9/10 centimeters. You plug in those numbers and do the math, you'll find that the density is 2.7 grams per centimeters cubed. The grams part goes with the mass. This is not writing very well. And then the centimeters cubed part goes with the volume. Can't talk. Finally, you're going to take this number and you're going to match it up to the rock table that is on your paper. And you've got about 10 different rocks listed there that you have to try to sort through. And there's only one whose density matches up to this, 2.7. That means this rock matches up to limestone. And there's a picture of it just underneath. So you need to write down the density and you need to write down the rock name on your paper. Our second rock's mass is 20 9/10 grams. The volume is 7 4/10 centimeters cubed. So again, start out writing the formula. Plug in your numbers. You've got mass of 20.9. You're dividing it by 7.4. When you do that math, you end up with 2 82/100 grams per centimeters cubed. Again, you're going to do the same thing. You're taking this number and you're matching it up to the density chart that you have above these problems. And the rock that this matches up to is called mica. And it looks really cool because it peels off in sheets. We'll learn about all these rocks later on in the year, but I just wanted to give you a preview of them now. The third one, it says this rock's mass is 20 1500 grams. The volume is 6 5/10 grams per centimeters cubed. And so we're going to plug in our numbers after we write our formula. I know it seems tedious to write the formula over and over and you're like, what's the point? But I just want to make sure you do that because on quizzes I'll give you 1 point for writing the formula just to show me you know where to start. Once you do the math, you'll have 20 1500 divided by 6.5, and you should find that your number is 3.1 grams per centimeters cubed. And so when you match up this density to the densities of the different rocks in your table, you should find that this one matches up to gabbro. It looks very much like the rock that you use in marble. Last one, this rock's mass is 22 80/100, so you could just say 8/10 grams, and then its volume is 11 2300 centimeters. Last time, D equals M over V. We'll have 22.8 divided by 11.23. Oops. Your density will be equal to 2 300 grams per centimeters cubed. The last matching that you have to do in the rock table, this goes perfectly with a rock called Arcos. Alright, so those are just the 4 problems that you had to work out. Be ready to show these in class when we come back together, and we will put all of this together to review before we take a quiz on metrics. Hope you have a good evening, and I'll see you in class.